Hey class, I wanted to take a chance to put together this short video to help explain some of the commonly misunderstood concepts, particularly those that we just went through in the Stage 2 exam. These are important areas to have foundationally, and you'll actually find, I think, that these concepts are really not that difficult to understand, but sometimes it might be tough to just grasp the concepts through reading alone. So that's why I wanted to put this together for you. And I'm going to use the landing distance graph here. The takeoff or landing distance graph, it doesn't really tell you which one it is, but it comes from your test, and the scenario at the bottom is also from your test. I wanted to use this to guide us through several crucial concepts. So, first thing is you're going to use the chart to, you're going to start at the temperature and go up to pressure altitude. So let's talk about pressure altitude. You sometimes will have to calculate the pressure altitude. Remember our scenario in the test, you had a lower pressure than standard. So how do you get pressure altitude, or what is pressure altitude? Let's start there. Pressure altitude, remember, is the altitude corrected for non-standard pressure. So you calculate that. I know that in your videos, your course videos, you had several options that you were given. Here's one more. You start with standard. Standard pressure is what? 2992. And you subtract your current altimeter setting from that to get the difference. In this case, the difference is 2.09 inches. 2.09, you multiply that times 1,000, or move the decimal place 3 places to the right. So your difference then between standard pressure altitude and current pressure altitude is 2,090 feet. So you take your 2,090 feet, you add your current altitude to it, and that came from your 1498. You add those two together to get 3,588 feet. That works both ways, actually. You'll want to remember that lower pressure is actually less performance. Remember, lower pressure, so 2783 is less performance than you would get at 2992. That's a higher elevation. So just kind of step back at the end of it and remember, or figure out, notice whether or not that answer makes sense or not. Okay? In this case, it does. Alright, that works both ways. Let me give you another scenario for pressure altitude. Another scenario, we have the higher altimeter setting. Let's say we have an airport elevation. Again, it'll be the same elevation, 1,498 feet. We're going to apply to this new scenario now with a higher pressure setting. So you take the standard altimeter setting again, 2992. You subtract the current altimeter setting. In this case, it's a higher altimeter setting, 30.08. That gives you a difference of negative 0.16. Okay? Again, same thing. Multiply that times 1,000, or move the decimal place 3 places. You end up with negative 160. And so you take that negative 160, subtract it from, or add to whatever you want to call it, but in reality you'll end up with a lower airport elevation because you have a higher pressure, higher performance, lower altitude. So you take the negative 160, add it to your current airport elevation of 1,498, you get a pressure altitude of 1,338 feet. Those are two scenarios, two different kind of scenarios with how to extract your pressure altitude. Pressure altitude, again, really all you're doing is you're comparing your current pressure setting to standard so that you come up with an actual pressure altitude there. Alright, so going back to our chart, they actually give us these scenarios. So you're at 10 degrees Celsius and 2,000 feet pressure altitude. Notice they already gave it to you. Sometimes they will, sometimes they won't. But in our case, you start at your temperature, go up to the actual altitude, pressure altitude that they give you, or that you have calculated, in this case 2,000 feet, and move across to your reference line. Notice that you're actually figuring density altitude into this scenario, because what's density altitude? Well, density altitude is the altitude corrected for both non-standard temperature and pressure. So you've accounted for temperature here, and you've accounted for the pressure and the pressure altitude. Okay, So you've moved across to your reference line now. Now we're going to talk about weight and balance. So you get into your weight scenario. Now let's take a pause from this real quick while we talk about weight. In your exam, most of you did very well in calculating the moment, multiplying the weight times the arm to get the moment. Most of you did well there. Where we struggled a lot, I think, was in figuring out the weights. And that's actually not one of the more difficult areas of weight and balance. So I'm encouraged, and you should be encouraged by that as well. Pay attention to the notes. Here's one of the first things I wanted to bring about. Pay attention to the notes. Oil sometimes is included in the basic empty weight, sometimes it's not. So pay attention to the notes. If the oil is included in the basic empty weight of the aircraft, you do not need to add it, nor should you add it into this. So you were given also a maximum gross weight of 2,950 pounds, and you have all of the other weights in your scenario. So all you have to do is come up with how many pounds are left to account for your main fuel. So just use your, add the numbers up, subtract the 2,950 to come up with how many pounds are left, and that's what your main fuel would be. Because your scenario said to bring you put as much main fuel in to bring you up to maximum gross weight. And then when calculating the maximum or the total fuel on board, that's really easy. Also, the difference is that you are also going to need to, in this scenario, add aux fuel. So main fuel plus aux fuel gives you the total fuel. You had to add the 180 plus the 90 to give you 270 pounds. Divide that by 6 and you'd have 45 gallons of total fuel on board. Okay, so that's a little aside on weight and balance as we work through that in our takeoff or landing distance scenario. In this one, however, you were given the weight of the aircraft of 2,500 pounds. So 2,500 pounds, we are at our reference line. Now you just want to follow down to your actual weight, which in this case was 2,500 pounds. And so you follow your way down to that line, move across to the reference line, and then we move into winds. Now, I'm going to give you a little bit of a preview on winds. We haven't gotten to this part quite yet in our class. For now, actually, the headwind or tailwind component has been given to you as it was in this scenario. But we're going to talk just a little bit about the headwind components. Wind is rarely, in real life, actually a direct headwind or direct tailwind. Usually it's a crosswind of some sort, so you have a headwind component or a tailwind component. You're going to be able to calculate head and tailwind components later in the course, and you'll use a chart similar to this, where you'll see if the wind component is a degree or two or 60 or 90 off of the nose of the airplane or off of the runway heading, and you'll be able to figure out what the headwind or tailwind component of that is. So that's for later. In our case right now, that scenario again is given to you. In our scenario, we gave you a pretty bad scenario of a 10-knot tailwind. In the 10-knot tailwind, then what you do is you work your way up, because notice that tailwind is up, headwind is down. So a tailwind obviously will increase your takeoff or landing distance. A headwind will decrease your takeoff or landing distance. So that makes sense that you have to go up 10 knots in this case to that tailwind component. Move across to your reference line and then up to your 50-foot obstacle. So again, it's going to take more distance to climb to the 50-foot obstacle. If you didn't have to climb over a 50-foot obstacle, you would just take that from the reference line straight across, and it would be less distance. But in our case, we have to go up across the 50-foot obstacle, and that gives us about a 2,000, and we gave you a little bit of latitude there as far as what would be counted as correct or not. But that's your calculated distance. I want you to notice that any change in any of these factors within the chart will change the outcome. If a change to temperature, altitude, pressure, weight, winds, any of those changes will actually change your takeoff or landing outcome. So pay attention to that also in real life. Also, remember the notes of if you're taking off on a paved, level, dry surface runway, or if you have a slope, or if you have grass or long grass or wet grass. All of those are going to make a difference in your takeoff and landing distances, and that kind of thing has gotten pilots in trouble in the past. So I wanted to take a few minutes to make sure that we actually get a good solid foundation on this information, and I hope that helps.